adding certain operators, additional basic operators that we need to learn, state operations, null values, aggregate function, nested subqueries, modification in the database. So today we'll focus 4 to 5 points from this outline. So starting with the history, when this SQL was invented, whether it is a good option to write SQL query or any other options are available where we can shift on the ID. That we'll see first. So IBM SQL language developed as a part of System R project in the IBM San Jose Research Lab. It was designed in the IBM Research. Yes. Any doubt? Okay. IBM Janros Research Library. So it was renamed as a structured query language. Structurally, we have to write a query and Excel language. So as it is a language means we have to follow the syntax and the protocol of that language. We cannot write any particular query in our own language. We have to follow the certain sequence that has been defined in a compile. So when you write a query, we have to first select the predicates, then we have to write a condition, and then we have to select the relation. That is the scenario or the protocol while writing the structured query language. There are different versions of SQLs are there, SQL 86, SQL 89, 92, 99, 2003, and nowadays people are using SQL 2019 as well. And all are used in the commercial purpose right now. SQL parts. What are the important parts in the SQL? DDL and DML, as I said in the earlier discussion, data definition language and data manipulation. In the data definition language, we have to define our relation. So whenever any application is given to you, you can define the data state or relation to the DDL. So in the DDL, we can create a relation, we can alter a relation, we can create a view of that relation, and we can perform the indexing operation by using DDL. So DDL role is to perform 4 different operations: create a relation, alter a relation, then create a view in the relation, and perform the index operation on the given relation. Now come towards the DML, that is the data manipulation. We can manipulate the data. So it means that we can insert into the relation, we can delete from the relation, we can modify that relation. So such a kind of customization operation we can perform with the data manipulation language. View definition, as I said, it is a part of DDL where we can create a view of the database and we can picturize that view for a certain purpose. Transaction control, it is particularly deal with the e-commerce application. Whenever there is a transaction involved, then how we can write a query. For example, here I give one example, very simple example to understand how the transaction control can be handled in the SQL queries. For example, certain customer want to withdraw 1,000 rupees from his account. We just fill the slip and submit to the cashier. Cashier just put an entry of that particular account number and the power failure is over. The cashier just enter the account number and an amount, and when you press enter, at that moment the power failure occurs. Now what will happen whether that transaction is being performed successfully or not performed successfully? Sometimes it may be possible that the query is executed. If the query is executed, it means that the amount is deducted, but it is not reflected in the user account. Sometimes amount is not deducted, but it is reflected in the user account. So such a kind of issues we can handle with the help of transaction control. There are certain protocols are there that we need to discuss in the transaction control. We'll see that controls protocol in the further discussion. Embedded SQL and dynamic. It is not in your syllabus. How we can handle this embedded and dynamic SQL. Authorization is also part of SQL query. Now coming towards the very first part of the SQL, that is data definition language. Now we need to understand what is the role of data definition language. As a word, data definition language. We have a data and we have to define that data in terms of particular language. So that language is now SQL, that is a structured query language. So what are the query you write in the editor or in a console? That all belongs to a structured query language. You cannot say it's a DDL, it's a DML, DSL. No need to mention anything when you write a SQL query. But it will be categorized. What are the terms under DDL? What are the terms under DML? What are the terms under DCL? Now, what is DDL? It's a schema for the relation. Schema means what? Just a minute. We will see this through the example. So I have an application, let's say any particular application. Let it be, I have an application of banking sector. These are my attributes in the relation: account number, name of the person or the account holder, and then let's say address or any particular attribute that we want to mention in this schema. So schema for each relation, this is nothing but a schema. How to write the schema for the relation? Let it be, this is my bank relation, and we need to write the schema for that. So schema for the relation is, let's say bank is a relation which consists of schema. Schema is nothing but the attribute which comes under that relation. So account number is one of the attributes under the bank relation, and other two attributes are, let's say, name and address. Name and address. So this is nothing but the schema for the given relation. So that schema we can design. After designing of this schema, we have to identify the key attribute. So account number is my primary attribute. So I just underline that particular. So this schema you have to design for that application. It may have one schema, it may have two schema, it may have many schemas are there as well. Depending on the application, you can design the number of schemas. The type of value associated with it. Now, type of value means what type of data that I'm going to store inside that attribute. Your first task is to write the schema, identify the key attributes. Once you identify the attributes, then decide the data type. What data type I'm going to use for this attribute, what data type I'm going to use for this attribute and this attribute. So let it be, I'm using integer for all the three attributes. Forgot about the name of attribute. Assume that all other type of integer type of attribute. Then we can write the integrity constraint. Integrity constraint are nothing but certain set of conditions. Let it be age of the person is less than 18, then the account should not be open, or should not be assigned any account number to that customer. So such a type of integrity constraint we can add, as well as super key. If the two keys are represent prime attribute in the relation, that we can write in the integrity constraint. So two constraints are there: conditional constraint and integrity constraint. Integrity constraints are nothing but related to key, and conditional constraints are nothing but default value I need to assign at the time of insertion. Next is set indices to be maintained of each relation. We have to maintain the indices of each relation that we can see at the time of implementation. Security and authorization information of each relation. So how we can give the security and authorization information of each relation? By maintaining the key attribute. That may be the primary key, that may be foreign key, or the candidate key. By giving that attribute, we can secure our tuples, or we can say the records under the relation. Then the physical storage structure of each relation on it. So whatever the data we store, that will be stored in the main disk or our primary location. That these are the points under the data definition language. Now these are the data type we can use while assigning the values in front of the attributes. So character is a data type, varchar is a data type which consists of combination of character and integer values, and we can set the maximum length to varchar inside the bracket. So there is a difference between char and varchar. In a char, we can store only string type of data or the collection of characters only. While in the varchar, we can integrate character as well as integer type of information to maintain the records. Integer to maintain the numeric type of information, small integer. Whenever you want to store very smallest value of the integer type, then you can use the small integer. Suppose I want to store the float numbers, then we can use a numeric. Real double precisions are also there. Float numbers also there. These are comes under same category. Now first query of our relation is create relation. Now the first part of the data definition language is create a relation. So you can create a one relation, you can create a many relation depending on the application. But how to write the SQL query for that? This is the syntax as good as one example over here. How to write the SQL query to create a relation. Those who not understand in the practical session, now it's again chance to understand how to write the SQL queries from the DDL and the DCL. If you miss the two practical, then it's a perfect session for you that you can learn how to write the SQL queries. Now this is the syntax. The very first point of discussion over here is many times students make the mistake while writing in the answer for this type of question in examination. For example, the question is simply like write the DTL commands. Write the DTL commands. So expectation is that you have to write the type of commands under the DTL, that is create, alter, update, sorry, view and index. These four commands are comes under the DTL, and you have to write syntax along with one example. Syntax along with one example. Do not write with the example. Every time you have to write a syntax in the theory examination. So syntax is create table. This is the result table under the SQL compiler. R is the name of relation. A1, A2, AN are nothing but the attribute. D1, D2, DN are nothing but the data type of that attribute. So depending on the type of attribute, we are going to select the data type. So we have to mention this data type in front of the attribute. So when you write the attribute, appropriate data type you have to write, either it may be integer, character, or it's a variable. Then integrity constraint, whether it's a primary key, whether it's a foreign key, or any kind of other constraint we can set after the attributes. So this is all about the syntax of create relation. Here, as I said, R is the name of relation. That is the table name. And as I said, A is the attribute, D is the data type of that attribute. Now you can see the example. Create table. These are the result keywords. Create table. Name of that table is instructor, and then attribute and the data type. Attribute data. ID is an attribute. Character 5 is a data type. So it means that I'm going to store character type of data in this attribute having size is 5. I cannot insert more than 5 character under that attribute ID. Similarly, name is a varchar. Having total length of that varchar is 12. Department name is also varchar. Salary is numeric 8 common. It means that 8 digit we can store, and fractional point or the decimal point 2 digit we are going to consider. So that value we are going to consider like this: 1002 8 digit, and then after decimal point it's only two values have been considered. So this is the create table SQL query. You can write this query, you can execute in the compiler, you get the relation is get created. Now, what sort of constraints are there? This example we just focused on the create table. Once the table is created, we cannot write the constraint directly. We have to alter. But at the time of creation, we can add a constraint. So we'll separately see how to add a constraint. So type of integrity constraint, it's a primary key, foreign key, or not. These three different constraints we can add as an integrity constraint in the SQL query. Any doubt in the create command? Is there doubt? Yes, I'm audible.
Yes, sir.
Yes, sir.
Yes, sir.
So coming towards the next integrity constraint, primary key, foreign key, not. So whenever you update any record or whenever you use a relation between the two different tables, that time these constraints are important. For example, this is one of the relations. This is one of the relation. Other relation. Two attributes are there. And this is the account number. This is also account number. This is the date of transaction. And this is the amount. And this is not a good database, but this is one of the database. This is the amount. Try to understand it. This is my account number in both relation. I just write the relation R1 and I write the relation R2. Two relations are there, R1 and R2. both relations and prime attribute account number, and this is date and this is the amount that is right now in the particular customer account number. So whenever I remove any record from this relation one, and if the same record is related to account number one, it should be deleted. So that is the delete operation. Whenever I add any record at this relation R1, it should be inserted into the R2. So such a kind of constraint we can say in the integrity constraint. So unnecessarily I am not going to write two times SQL query to insert the record because that relations are dependent. These two relations are related to each other. If these two relations are related to each other, it means that we can add a record in one relation, it should be related to another relation. Then we can perform many operation on that relation. R1 dot R2, R1 plus R2, that we'll see in the next unit how to operate this R1 plus R2, R1 into R2, or we can perform R1 is joined with R2. So such a kind of operations we have to perform afterwards. So when you perform this operation, there should be a relation in these two relations. There should be a relation between these two tables. If there is no relation between the two relation or a table, then we cannot use the integrity constraint properly. So add the integrity constraint in the relation to make that both the relations are related to each other. How to write that constraint? As we had already discussed what is primary key, what is foreign key in the first unit. Again, we'll talk about what is primary key and the foreign key in this create command. So again, I just write command create table instructor. So this will be keyword create table, name of the relation, that is the instructor. This is the first relation R1 I'm talking about. Name of the relation is instructor. After that, we have to mention the attribute data type. Attribute data type. So whenever I write this attribute data type, there is one more keyword is there not null. It means that name should not be null. So when you add any record in the relation, that time your name should not be null. And if it is null, it won't be allowed in the SQL query or it won't be inserted into the relation unless and until you enter the name of the student or name of the instructor. Department name, SUMAD camp, salary, whatever the data type we selected in the previous command as it is this data types. After that, we have to set the integrity constraint. Nowadays, it is very easy that in the console you can right click and just set as a primary key, you can set as a foreign key. But if you're using the SQL prompt, that time we have to write it this name of the primary key, name of the foreign key. At a time, we can add multiple primary key for the relation, multiple foreign key for the relation. But make sure that when you use the foreign key, that time at least two relations are there. For primary key, we can use in one relation. But if there is more than one relation, then we can set a foreign key for the particular attribute. So primary key is an ID. So this ID is now primary. In some of my lab, in front of this data type, you can write a primary key as well. This is also the correct syntax to write the primary key in front of this attribute. Attribute, data type, comma, then name of the integrity constraint. That is the primary key. Foreign key, name of the foreign key. Department, this is the name of the foreign key. And at what particular relation will reflect in the department. So foreign key is a department name which is references to the department. So department is one of the relation which having the key department name. And it is a foreign key for the relation instructor. So that relations we have to use while extracting the data. And so this is the one more example. Create table student with ID name, department name, total credit for the student, primary key is ID, foreign key is department name, references department. Likewise, you can save this relation. One more relation, create table text. These are the attributes. Primary key, you can see now. Primary key, ID, course ID, section ID, semester, year. More than one primary key also we can set to the relation. So these all are the primary key for this relation text. And foreign key also more than one foreign key. More than one relations we can use in the foreign key. Hope you understand that how to set the integrity constraint in the relation. If you put out one, you can ask. किसी को डाउट है कुछ क्रिएट टेबल की क्वेरी में भी समझ गया सबको कैसे लिखना है क्रिएट टेबल? यस और नो?
सर थियरी एग्जाम में क्वेश्चन कैसा आएगा इसका?
theory examination is a very simple question. Write the DDL commands. Write the DDL commands. There are 4 commands in the DDL. That's the create command, alter command, view command, and text command. You have to write the syntax of this create command along with one example. So you have to write this example. Let's say this is the syntax to create the relation, and this is an example. So likewise, you have to just write in terms of SQL. No need to write any explanation about what is ID, what is character, what is name, what is backup. Like this. Just you have to write the SQL query to understand how you can create
Okay,
a
sir.
table. So this is about the create relation. I think no kind of difficulty up to this point about how to create the relation along with the integrity constraint. Now update it relation. Once we create the relation, then definitely alter it. We can create a view. But before that, we need to add a record inside the table. Unless and until we cannot insert any record in the relation, we cannot operate it. First of all, insert few records in the relation so that you can write SQL queries or you can retrieve some data according to the need of application. So first I just create a relation. After that, I'm going to insert it to the table. So how to insert the data into the table? This is just an delete drop table alter command. After this discussion, we'll see separately how to insert a record, syntax for insert along with their example. But to perform any operation, we have to insert certain record. So insert into relation. Insert into name of the relation is instructor. Values name of the attributes that we mention in the relation. So 1, 2, 3, 4 values we are inserted in this instructor relation. ID, name, department name, and I think salary. Instructor that we instructor ID name, salary. So these are the attributes. For that I have to insert the value. So insert into is in keywords that we write in the SQL query. After that, name of the relation, that is instructor, and the attributes, ID, name, department name, salary, 4 attributes are there in the relation instructor. And then the actual values that I want to insert. So I'll write the values and the actual values that I want to insert. So this command you can execute and you will get the result as the record is inserted. So once you write this SQL query, one record is been inserted into the relation and that is reflected in your table. So at a time one record we can insert it right now. But it is also the possibility that more than one record also we can insert at the same time. More than let's say 100, 200 record also we can insert at the same time by using PL/SQL block. By using SQL command, it is not possible to insert many record by using single SQL step. For that purpose, we have to use the PL/SQL block. That we will see in the further discussion. So right now, we can insert one record at a time in the SQL relation. Then delete command. Delete command will delete all the record from the relation. But if I not write any condition in the delete command, my complete records has been removed or all the values or tuples are there in the relation that has been removed from the relation. So if I write delete from should, it's a very straightforward command like delete from name of the relation. So delete from instructor, all the data of the instructor is deleted. If I not write any condition. So when you write in delete command, make sure that you have to select a proper attribute, you have to select a proper condition while writing the delete command. Once you delete the record, you cannot recover that record. If my delete command is executed on a relation of the instructor or a student, that whole records are get deleted. I cannot recover that record at any cost. So make sure that when you write delete command, be sure you write a condition. Without condition, do not write a delete command in any relation. Then if you want to delete a complete relation or a table, you can use a drop command. So drop table and the name of relation. Suppose I want to drop the instructor. There is a difference between drop and delete. In a delete command, we can delete only records. So what are the records are there in these relations that are get deleted? Suppose I write a command delete from R1. Delete from R1. These records are get deleted, but table is exist in the database. If I write a drop table, it means this complete relation is get dropped from the database. We cannot insert any record in the relation R1. We cannot modify R1 because it is not exist if I perform the drop table. So hope you understand there is a difference between delete and drop. Delete will delete the tuples or you can say the record, while drop will drop the attributes. So drop will perform operation on the columns, while delete will perform operation on the row. Make sure this is the difference between the drop and delete. Alter command. In the alter command, yesterday we discussed there are many ways are there we can write an alter command. Either we can alter table with an attribute, alter table with a data type, or alter table with remove the attribute. So three different ways are there. We can write an alter command. We can add a column, we can delete a column, and we can make the modification in the data type. Alter command is specifically used when there is no any key attribute is set in the relation. Otherwise, it is very difficult to alter the relation. Next is select command. Now, once we insert a record in the database, then we can select a certain record. Select attribute from relation where condition. This is the way that you can write a select command. Select from where these are the called as predicates. These three predicates are required in a select command. Select star from relation where certain condition I can write. So that condition will execute and will get an outcome in terms of records. That may be one record, two record, or any number of records. Fine. So select will select a certain record. Now how the select command is going to be executed? Just a moment. If I have this relation with certain attribute, I'm not going to write name of attribute now. Just create the empty relation here, and I just write a command. Let the name of the relation is R1. Name of the relation is R1. If I write select star from R1, so first it will select star. Star means all the attributes of that relation. So it execute from this end, select star. So it will select all the record from relation R1. So it will select record from R1. Whenever you execute the select command, select star from relation is execute first. So whenever you execute any select command, it will execute select attribute from relation. From that relation, it will select the particular attribute. And then it will execute for a condition. Then will execute for a condition. That where clause is applicable after selecting the records. So once I select all the records, then I have to apply the condition to filter out some records. That condition is, let's say ID is greater than 5, age is greater than 10, or birth date is so and so. Any conditions we can write inside the select command. Where clause can be alternatively used by having clause. So either I can use a where clause or I can use the having clause. We'll see afterwards how to use the having clause. Right now, select star from table where condition is so and so. So hope you understand that how to write the select command.
Yes, sir.
How it executes already to this. And this is one more important thing. Let's say I write a query. So this is one of the question that you can see in your theory examination. Find the department name of all instructor and remove duplicates. This is the query that I want to write. So sometimes relations are given, tables are given like this in theory examination along with the records, and you have to filter out some record. Find the department name of all instructor and remove the duplicates. Whenever there is a word find, that time always go with the select query. That time we have to go with the select query. Whenever there is a find the attribute, find the records, that time select command is used. Select department name from instructor. So select department name from instructor is been saved all the department. But our query is that we have to remove the duplicates. So either we can remove the duplicate first from the relation and then we can write a query. If I just use a query select distinct department name from instructor, it will select a distinct department from the relation, but duplication is still exists in the relation. जो भी duplication होगा वो relation के अंदर as it is preserve होगा. Just we are selecting a distinct department name from an instructor. So it will filter out the unique record from the relation instructor. But the duplication is exist in the relation. That's why we need to normalize that data. See that unit number 4 is normalization. So hope you understand that how to select the distinct record from the relation. This distinct is a keyword under the SQL compiler. So many keywords are there that we can use. Like we can perform sum, we can find the count, we can find the mean, we can find max, we can organize the record in ascending order, we can organize the record in descending order. We'll take one example and we'll write all the SQL query for that example in the theory session as well. So to understand how to remove the duplicates from the given relation. So this next command, select all department name from an instructor. It will select all the department name which is under that instructor. If I'm not using this all keyword, then also all the departments are going to display. So this is an optional one if you want to use, you can use. Otherwise, it will definitely retrieve all the department from the relation. Select star from SQL. So star is nothing but all that root. Already we discussed this, how to write the command by with select star. So star is going to be retrieve all the attributes from that relation at the once. So we'll get all the tuples, all the records of that relation with the single SQL query. Now, see, an attribute can be literal with no from a class. So select 437. Can we write this 437 select 437? Could be this relation name? No. So when you write the database name, it cannot be a numeric. It should be a character name so that we will get a record. But by mistakenly, you will get some data set having the name is in terms of numeric value. Let's say 437. So you need to make the alignment of that attribute or of the database. So you can align the database like this. Select 437 as FW. So it will be aligned with this attribute, and then we can retrieve the record. Now, this kind of operation is also possible with the select class. Suppose I want to find out minimum marks, maximum marks. If I want to divide the attribute with certain value, then also we can do that in the select class. So these are the arithmetic operations we can perform on the select class: plus, minus, multiplication, and the division. Select ID, name, salary, divide by 12 from instruction. I'll show with one example. Exam server, yam karke dekh. So that will get a clear idea. About dbms lab. I think customer is there. So we need to check any attribute there. We can perform the operation. So let's say customer discount. So it's visible to all.
Yes, sir.
Yes, sir.
Okay. So So here the customer discount is 5%, sometimes 4%. I want to multiply this value with the 2. I want to give the customer discount multiply with the 2 or any in terms of percentage. We can write in terms of 10%, 20%, we have to increase. Then also it is possible. So how to write the SQL queries for that? You can see in this presentation. Select ID name salary divided by 12 from inspector. How this operation is going to be performed? How these arithmetic operations can be worked in the SQL command? Now we will see this. Name of the relation is customer. I just show you that how we can achieve that arithmetic operation in the SQL query. So select, we can write the name of attribute. Let's say select customer is in my relation. Having the columns are customer address. Select customer address. So customer ID, and customer discount. I have to multiply with 2. So what are the discount that customer? Now it's multiplied by 2.
Sir, we are not able to see the prompt. PHP MySQL.
Now
Yes, sir.
it's visible.
Yes, sir, it is visible now.
I think it is not correct. So select customer address. This is the attribute that I want to select. Customer ID that also I want to select, and I want to multiply this customer discount value into 2. So what are the value right now in the database? It should be multiplied by 2, and it is the display from name of the relation. Name of the relation is customer. So this is a whole query that we can just multiply with this value with the 2. As good as we can make the alignment of this attribute. See afterwards how to align that. Just I'm going to execute this first. Error is there. Customer ID does not exist. So is there any record? Customer ID is not exist. Yes, customer ID exists. Any mistake in that? We'll just write again one more time. Select customer ID, customer name, customer discount is multiplied by 2 from name of the relation is first. I think it is correct. Select attribute from relation. See, the values get multiplied by 2. You can see now the column name is also get changed. Customer discount multiplied by 2. आपको दिख रहा है? It's visible to all.
Yes, sir.
Yes, sir.
Yes.
Now you can see the name of the column is also get changed. Customer discount multiplied by 2. But I don't want to give the name of this column like this. I want to give some other name. Okay, so I'll just edit this query as customer change discount. So this is the name of the attribute that I want to be changed in the original relation. So when these queries get executed, select customer ID, customer name, customer discount attribute should be look like this now. So I'll just again execute this command, and you can find the name of that attribute get changed. So likewise, you can write this query with certain arithmetic operator like multiplication. I can also subtract with 1 or any particular operation that you can perform. Divide with certain value, add with certain value. Any particular mathematical operation you can perform on that particular attribute. Hope you understand that how to perform the mathematical arithmetic operation on the given relation. But make sure that that value should be in memory. If it is in character value, we cannot operate that value in terms of arithmetic operator. I cannot multiply the customer name. If it I multiply, there is no use of customer name to multiply. So depending on the type of data, we have to perform the arithmetic operation on that data. So hope it is clear now to everyone how it will work in the
Yes, sir.
exam. So this is all about on this session. Just a minute, let me check. There was okay. This will we have next session. So up to this point, any doubt from your end?
So can you explain that select 477 as FOO? That one a point.
Select.
Means what it will give the output.
Just a minute. So, we require the same attribute of that type in the relation. If it is not there, we have to add that. But right now we have a proper attribute. When we get the data, we cannot create that attribute in this relation. But if I have a data set which consists of numeric value attribute, that time we can make an alignment. But here I'll show you some example. Let's say I have two relations. It's a customer and student. We have this two relation, customer and a student. How we can analyze that relation? Select start from customer. Select start from student. We have these two separate relations. At that time, we can analyze this as, let's say, customer. We can analyze this as student. But if I have an attribute 437, then we can do that for any kind of attribute. This again the previous here. Customer discount ads, customer change discount. So if that attribute is exists which having numeric value, then we can write like this as, let's say, roll number. This is the attribute that I want to change. आप लोग इस तरीके से कर सकते हैं.
Okay, sir.
I can analyze attribute, I can analyze relation, I can combine two different relations. So just let it be this is the two SQL query here I write. Here I just write star, select star from student. And when I want to connect these two relations, that time we can directly use C1 dot customer address, C1 dot customer support. वो हम देखेंगे further discussion. Next है फिर उसके next discussion ये वो ठीक है.
Yes, sir. Thank you.
किसी को कुछ other doubts? So any doubt? Just give your attendance. Stop.